Hi guys, welcome to the YouTube channel, Romano Giuseppe, Electronic and CNC Lab. In today's video, we will see the first step, but also the most important and delicate one, which I performed. To upgrade my CNC 3018, or how to calibrate the stepper motor drivers A4988, this operation is essential before connecting them to stepper motors, for two reasons. The first is that when we buy A4988, we don't know what maximum current per phase they have been adjusted to. Second reason is that not all 3018 printers have the same stepper motor model. So the phase currents can vary. But let's start with some useful recommendations and some information. The A4988 drivers must be handled with caution, as they are sensitive components to electrostatic charges. To avoid damaging them, handling them with the electrostatic currents we have on us, I suggest you get an anti-static bracelet. The heart of this circuit is the driver, the black square component. This chip, in fact, with the addition of a few passive components, resistors and capacitors, is able to drive a stepper motor with different step resolutions: full step, half step, quarter step, 1/8 step and finally 1/16 step, thus allowing a 200-step, revolution stepper motor to work even with 400, 800, 1600 and 3200 steps, revolution. Moreover, this component is able to generate the quantized and bidirectional currents, to be sent to the two phases of the stepper motor. Now let's see the material I used to upgrade. An Arduino Mega 2560 Rev, 3 border ramps, 1.4 card 3A4988 drivers complete with heat sinks and anti-static bracelet, a Phillips screwdriver, a multimeter, or tester. Let's see now what information I need. The first is the exact abbreviation of the stepper motors mounted on the CNC. With this information, looking on Google, I found the datasheet of my model, and from there I discovered the phase current. In fact, on my CNC there are 1.3 ampere NEMA 17s, with the code 17HS3401. Another very useful information concerns the A4988 drivers. Looking at him closely with a mobile phone or a lens, it is necessary to identify the two sensing resistors. Therefore, it is necessary to read the abbreviation, which indicates the value. It is not certain that on all versions of this driver, made by different manufacturers, values equal to those of the example are found. In my case, I found two sensing resistors with the abbreviation R100, which is equivalent to 0.1 ohm. Now let's look at the formula in the lower part of the screen. This formula was taken from the datasheet of driver A4988. In fact, we need it to determine the Vref value, and it is used to adjust the maximum current that can be supplied by the driver. A value too low, it would cause the engine to lose torque and steps. A value that is too high, it would overheat the engine and damage it in the long run. Now take a calculator. Imax is the current of the stepper motor, obtained from the datasheet. In my case it was 1.3 amps. Rs is the sensing resistance. On my drivers it was 0.1 ohm. By inserting the values in the formula you will get Vref. In my case I reduced Vref to 70%, i.e. 0.728 volts, in order not to make the stepper motors work at 100% of their current. Also, in the processing of printed circuits the mechanical load is not so high, and I have found that the engines do not lose steps. Now let's move on to the ramps 1.4 board. This board is an Arduino Mega 2560 Shield, and was initially designed to manage the hardware of the low-end, economic, 3D printers. Is able to manage 5 stepper motor drivers, 3 power loads, temperature sensors, a graphic display, buttons and rotary encoders. In the case of a CNC milling machine, the task that the microcontroller has to manage is much lighter. In this slide, you can see the ramps 1.4. At the bottom we have the driver housing, the 3 colored jumpers. In fact, it is thanks to the configuration of those 3 jumpers that the driver step configuration is established, with the 3 jumpers inserted, that, at 4988, he works in microstepping at a 1/16 of a step. Let's start with the assembly of the various boards, but first put on the anti-static cuff. Then take the Arduino Mega 2560 Rev.3, and graft onto the ramp's 1.4 shield. Pay attention to the alignment of the 2 boards, in order not to make a mistake, during insertion. Align the 18 by 2 pin female connector of Arduino Mega with the 18 by 2 pin male connector on the ramp's 1.4, visible on the right side of the board. Proceed with caution and couple the 2 boards proceeding parallel. At this point, take the drivers, attach the small heatsinks, centering them with respect to the chip, making sure that the metal edge does not touch the surrounding components. Then take the drivers and insert them in the ramp's 1.4 slots. Be careful not to mount them as it happens, they have only one orientation allowed. Look at the photo. Because mounting them backwards could damage both the driver and the Arduino Mega. Now let's see one of the possible calibration modes. To simplify the procedure, connect the negative of the multimeter to the GND of the terminal board, instead the positive of the multimeter. You must connect it with a cable terminated with a crocodile to the metal part of the screwdriver. Now turn on the multimeter on volt DC full scale 2 volts. Connected the USB cable to the Arduino Mega board. First make sure that no firmware is loaded, and then connect the other end to the PC. This operation only serves to supply the 5 volts. Now act with a steady hand, with the screwdriver on the small metal trimmer, as shown in the video. With small clockwise rotations it should increase the read value, counterclockwise it should decrease. In my case I adjusted the trimmer until reaching the value, which in my case was 0.728 volts, or 728 millivolts, or at least try to get as close as possible. Because the trimmer excursion is less than 1 turn, and it is very difficult to hit the exact value, proceed in the same way, with the other 2 drivers. I report below 2 other equivalent schemes for the purpose of adjusting the drivers, but with slightly different hardware. Finally, the operational video on how I performed the calibration. Well guys, at this point we are done. Let me know your impressions in the comments, and if you liked this video, remember to leave me a like, keep following my channel, and if you want automatic alerts every time I upload a new video, subscribe to the channel. Do not miss the next video, because we will see the self-built board for the control of the spindle and the interface of the probe. See you soon.
Bye.